Hi, once again welcome back to Triple E tutorial channel. Here in this video, we will see the equivalent circuit of a transformer. Through this video, first we will see what is the need of an equivalent circuit to make the equivalent circuit. Okay, next we will think about what are the major considerations they are needed for making the equivalent circuit of a transformer, and finally we will make the equivalent circuit of a transformer referred to primary and referred to secondary. So these are the major aim that we will see throughout this video. Okay. So first of all, we have to think about what is the need of finding the equivalent circuit of a transformer. We know that to design a transformer, we have to consider some parameters. So for the designing of a transformer, we will get the overall performance of a transformer if we consider the equivalent circuit. So first we can write, we will get the overall performance. We will get the overall performance if we consider the equivalent circuit of a transformer, and we will get the regulation. Regulation is nothing but the variation or the change in terminal voltage from no load to full load condition. So we have to get the regulation of a transformer if we consider the equivalent circuit, and we will get the efficiency, and we will get the overall performance under various load conditions. Okay, so we can write this point here. Overall performance under different load condition. Different load conditions. Load conditions can be of if the load is resistive or inductive or capacitive. And we will make the equivalent circuit of a transformer based on two test results. So what are the two test results? One is nothing but the open circuit test. Open circuit test. From the open circuit test, or it is also known as no load test. From this test we will get iron losses, our ultimate aim is to find out the iron losses. And the second one is short circuit test. Short circuit test is mainly used to find the copper losses. So considering all these things, we will find the efficiency of the given transformer. So we can design a transformer by considering the equivalent circuit parameters. So this is the main or important need of finding the or understanding the equivalent circuit of a transformer. Okay. First, here we have to draw the main considerations for the equivalent circuit of a transformer. For that, first we have to draw the basic symbol for the transformer. Okay. Primary winding and secondary winding. We know that to make the equivalent circuit, we must consider the resistance and reactance of the both windings, primary windings and secondary windings. So we have to represent that resistance of the primary winding and the reactance of the primary winding. The resistance of the primary winding can be represented as R1. Reactance of the primary winding can be represented as X1. and we are giving a supply V1 to the primary winding, or the primary side we are giving a supply V1. I1 is the total current which is flowing through the primary winding. It is nothing but the sum of I0 and I2 dash. In the previous video, I have already explained how the primary side current I1 become the sum of I0 and I2 dash, or what is the need of I2 dash here already. For more details, you can refer my previous video. Okay. So similarly, I can represent the secondary winding resistance R2 and secondary winding reactance X2 here. And normally the secondary side is normally connected to the load, so that I can represent the load impedance is ZL here. And this is the secondary winding resistance R2, and this is the secondary winding reactance X2. I2 is the load current which is flowing through the load or the secondary side when the secondary is loaded. Okay. When we give a supply V1 to the primary side, then what will happen? This will create an EMF E1 in the primary side due to the production of the flux, main flux, and the same main flux will completely passes through the core, and which will cuts the secondary winding, and this will create an EMF E2 in the secondary side of the winding. Okay. If we consider an ideal concept or ideal transformer, then under ideal transformer means it has an efficiency, 100% efficiency, no losses. All the things are already we have discussed about that points. At the initial condition, if we consider the no load condition, then I0 is the no load current which is flowing through the primary winding side, and I0 is nothing but the no load current. It has two components, IW and I mu. IW is nothing but the working component or loss component. I mu is the magnetizing component or lossless or wattless component. The main function of the magnetizing component I mu is to make necessary flux. So under no load condition and load condition, both conditions, I mu will be there. So IW, the working component, will be active when the transformer is connected to load. Okay. And we have already discussed the phasor diagram of the ideal transformer in detail. So once again I will draw that. Flux phi, when due to the supply V1, the same flux E1 will induce, due to the same flux E2 will induce, and both E1 and E2 both are 180-degree out of phase with the V1. So I have to draw this like here. Magnetizing component I mu will be always in phase with the main flux phi, and this is the no load condition diagram for an ideal transformer. And if we consider the practical transformer on no load, then IW will be there. The resultant of the IW and I mu will give you the no load current I0. So we have to draw this point here, I0. Here the current I0 is coming. We have to represent I0 on the basis of IW and I mu. We know that for a resistive load, we know that voltage and current both are in phase. That means here IW is in phase with V1. So I can represent IW as the resistance simple, and I mu is the magnetizing component. I can represent it, here I can represent a resistance, okay, and IW, here it is magnetizing component I mu. I can represent it like the symbol of an inductance symbol, okay. So this is the equivalent circuit of a transformer. It is slightly complicated to represent all these things like this. So we have to reduce the equivalent circuit by considering all these things. All these things we will consider. So I forgot to draw V2. V2 is nothing but the voltage appearing across the load or the secondary terminal voltage V2. So next, in the coming slides, we will consider to make the circuit simple, we will convert either all the components referred to the primary side or all the components of the primary side referred to the secondary side. Okay, so we can discuss about that in the coming slide. Here I considered all the components of the secondary referred to primary, or I can say here we are going to discuss the equivalent circuit of a transformer referred to primary, or I can say the secondary referred to primary. That means in this case we are converting all the components of the secondary sides to the primary. We are going to consider that. To convert these, first of all we have to draw all the things in the primary will be there, and the components from the secondary we are going to represent in the primary side. So first we can draw primary winding resistance R1, primary winding reactance X1, secondary winding resistance R2. Here if we are transforming the secondary sides to primary, then it will be known as R2 dash, and similarly secondary winding reactance X2 dash. Dash means which is coming from the other side. 2 means secondary. Okay. And I0 will be here. And the load, we need to convert the secondary load impedance ZL to the primary side. These are the things that we transformed from the secondary to the primary. Load impedance will be known as ZL dash when it convert into the primary side. IW, I mu, I0, I2. Here it will be I2 dash, and similarly V2 when it is referred to primary, it will be known as V2 dash. And similarly, I have to draw E1 and E2 dash. E2 dash is nothing but the secondary induced EMF which is converted into primary side, then it is known as E2 dash. Okay, here it is R1, X1, supply voltage V1, I1 will be here. So here we can check that whether all the components of the secondary referred or converted into the secondary. Here R1 is the primary winding resistance, X1 is the primary winding reactance. R2 dash and X2 dash, both quantities are coming from the secondary side. E2 dash from the secondary side, ZL dash load from the secondary side. I2 dash is the load current. Now it is referred to the primary. Okay. To convert all the things from the secondary to primary, we have to follow some rules. That is, first rule, if we consider the resistance, reactance or impedance or load impedance, whatever it is, we must divide these things with the k square. The rule is applicable only when we consider all the parameters referred to primary. Okay, the first rule is that if we transfer the resistance, reactance or impedance transferred from secondary to primary, then it must be divided by k square. That is, when the secondary resistance R2 transferred to primary, then it is known as R2 dash. So R2 dash will be equal to R2 divided by k square. So I can write here R2 dash will be equal to R2 divided by k square, and similarly X2 dash will be equal to X2 divided by k square. I can write here X2 dash will be equal to X2 divided by k square. Okay, and here impedance, load impedance ZL dash is equal to ZL divided by k square. So this is the first rule regarding the components resistance, reactance and impedance. We know that the units of all these things are ohm. Right. Okay, next thing is that we transformed current, secondary current. I2 is the load current at the secondary side, and if we transfer the secondary current I2 to the primary side, then it will be known as I2 dash. So we have to, if we transfer the secondary current I2 into primary, then it is known as I2 dash. Then I2 dash will be equal to I2 into K. We have to multiply I2 with the K. What is K? K is nothing but the transformation ratio. Okay, already we have discussed about transformation ratio in detail in my previous video. K is nothing but the ratio of, what is K? K is equal to V2 by V1 or E2 by E1 or N2 by N1 or I1 by I2. This is the expression for transformation ratio K. So we have transformed the secondary current I2 to I2 dash. And next we transformed voltages. Secondary voltage V2, when it is referred to primary, it is known as V2 dash. V2 dash must be equal to V2 divided by K. Here we divide secondary voltage to transformation ratio, and What is E2 dash? E2 dash will be equal to E2 divided by K. So I will explain once again. If we transfer all the parameters from the secondary side referred to primary, we have to follow some rules. We know that what are the major requirements at the secondary side. It is resistance, reactance and impedance of the windings. Impedance of the wind and load impedance. Okay. All these if we transfer all these parameters to primary, we have to divide this with the K square. So R2 dash will be equal to R2 by K square and X2 dash will be equal to X2 by K square. Load impedance ZL dash will be equal to ZL by K square. Similarly, if we transfer the current, one current is there, that is load current I2. If we transfer the load current I2 to the primary side, then it is known as I2 dash. That I2 dash will be equal to I2 into K. We must multiply the secondary current, load current I2 with the transformation ratio K. And the third thing that we will transfer from the secondary to primary, that is voltages. V2 is nothing but the load voltage, and if we transfer the secondary load voltage V2 to the primary, then it is known as V2 dash, which will be equal to V2 divided by K. And secondary induced EMF E2, in the primary it will be known as E2 dash, that will be equal to E2 divided by K. You have to remember these three things which are essential for making the equivalent circuits. Okay. These rules are just a reverse. Reversely, we will apply for if we consider all the parameters are referred to secondary. So we will think about in the coming slide. So based on these things, we will make a reduced circuit, that is, we know that R1 and R2 dash both are in series. Similarly, X1 and X2 dash both are in series. So what is the main rule? If the resistance are connected in series, then we can add the resistance, right? So I can draw the circuit like this. R1, R2 dash, X1, X2 dash. For the simplification of the circuit, I just eliminate I0 because now we consider the transformer is under load condition. So we can slightly, the value of I0 will be slightly negligible. So I can avoid this portion. So load impedance ZL will be here. This is nothing but R1 and it is R2 dash, X1 and X2 dash. So this and here V1, here load impedance ZL dash, E1, E2 and V2 dash will be here. Okay. The combination of R1 and R2 dash both are in series, then we can add these two things, R1 plus R2 dash. R1 plus R2 dash is nothing but R01. R01 is nothing but the equivalent resistance of a transformer referred to primary. And similarly, X1 and X2 dash both are in series, so we will get, if we add both of them, if both inductance are connected in series, then the equivalent will be the sum of both of these two. So X1 plus X2 dash will give you X01. So finally I can draw the simplified circuit by considering all these things: resistance, inductance and load impedance. Here it is V1, it is V2 dash, E2 dash will be here, E2 dash will be here, and E1 will be here. Okay, the space is not enough to draw that. E1 and E2 dash will be here. Okay, so this is R01 and this is X01. The combination of resistance and reactance will give you impedance Z01. So this is the final simplified circuit diagram, simplified equivalent circuit of a transformer. This will give you the overall performance of the circuit referred to the primary side. Okay, so here we will convert all the components of the primary circuit or the primary side referred to secondary side. Okay, so first I can draw the basic equivalent circuit, that is primary winding resistance R1, primary winding in reactance X1, and the I0, IW and I mu, IW and I mu. This is the primary winding and the secondary winding. Secondary winding resistance R2, secondary winding reactance, and load impedance ZL. This is R2, X2, R1, X1. We are giving V1 supply to this and I1 will flow through this. I2 will be here and this is V2. E2 is the EMF induced at the secondary winding due to the main flux. E1 is the primary winding induced EMF. So this is the basic equivalent circuit of a transformer. Here also we will see some rules which are needed to convert all the things from the primary to the secondary side. That is, if we consider all the resistance, reactance and impedance to the secondary side, we have to multiply this with K square. So first the rule is, if we consider all the resistance, reactance, all the resistance, reactance or impedance is transferred from primary to secondary, we have to obey some rules. That is, when we transfer the primary winding resistance R1 to the secondary, then it is known as R1 dash. R1 means primary winding resistance, dash means which is coming from the primary side, and now it is referred to the secondary. So here discussing about we will discuss about all the circuit parameters are referred to secondary. Okay, so R1 from the primary, now it is referred to secondary, then it is known as R1 dash. R1 dash will be equal to R1 into K square. In the other case, we discussed that R2 to the primary side, then it is divided by K square. Here all the resistance, reactance or impedance from the primary side, when it is referred to secondary, then it must be multiplied by the K square. Similarly, I will get X1 dash will be equal to X1 into K square, and similarly the combination of R1 and X1 will give you Z1 dash will be equal to Z1 into K square. Load is also always present in the secondary side. Okay, and if we transfer the currents from the primary side to the secondary side, That the then we know that the primary current is nothing but I1. When it is transferred to the secondary, then it is known as I1 dash. I1 dash is nothing but which is equal to I1 divided by K. Okay. Similarly, if we transfer the voltages, voltage means voltage present at the primary side is nothing but V1. When it is transferred to secondary, then it is known as V1 dash. V1 dash is nothing but which is equal to V1 into K. And similarly, there will be one more voltage, that is induced voltage E1. When it is transferred to secondary, it is E1 dash. E1 dash is nothing but E1 into K. These are the rules that we have to consider to transfer from primary to secondary. So here all the components are transferred to the secondary side. Okay. Based on these things, I can draw the next simplified circuit. That is, I am converting all the components to the secondary side. Okay. So I can write this here. Primary winding resistance, that is R1. At the secondary side, it is known as R1 dash. And this is X1 dash. And this is X1 dash, and the secondary winding resistance R2, X2, load impedance ZL will be here. Okay. E1, here it is E1 dash, and E2 will be here. V1, here it is known as V1 dash, and V2 will be present here. V2 will be here. Okay. These are the major things. And similarly, we know that R1 and R2 both are in series. So I can draw a circuit like this: R1, R2 dash, sorry, R1 dash, R2, X1 dash, X2, and here the load impedance. We know that the combination of R1 dash and R2 will give you R02. Similarly, the combination of X1 dash and X2 will give you X02. All the things will be here. V1, V1 dash, V2, E2, and similarly E1 dash. Okay, all the things I have to draw here. And by considering the lows, I can write R1 dash and R2 are in series, so I can draw a simplified resistance here. And similarly, R1 dash and X2 both are in series, so I can simply draw the circuit. This is the load impedance. This is R02, X02. The combination of this will give you Z02. So this is load voltage V2. So this is a simplified circuit of the transformer referred to secondary. Okay. So we have discussed the equivalent circuit of a transformer referred to primary and equivalent circuit of a transformer referred to secondary. and we discussed some rules regarding needed to make it a simplified equivalent circuit of a transformer. So I can once again write the rules here. The first rule is, if we consider all the components of the parameters from the secondary to the primary side, that is known as equivalent circuit of a transformer referred to primary. That means here we are converting all the parameters from the secondary side to the parameters. So what are the main parameters? Nothing but resistance, reactance, and impedance. We can include these things in a single category. And currents, and the third one is voltages. If we transfer all the resistance, reactance, and impedance from the secondary side to the parameters, we must divide it with k square. The first case, it is R2 is the secondary resistance. When it is converted into primary, it is R2 dash. So R2 dash will be equal to R2 divided by k square, and similarly X2 dash will be equal to X2 divided by k square, and Z2 dash will be equal to Z2 divided by k square, and load impedance ZL dash will be equal to ZL divided by k square. We have to remember these rules, these equations, which are essential to find out the problems during the exams. These are the rules that you have to remember. If you convert all the currents from the secondary side to the primary side, we know that the current, only one current present, that is I2. If you transfer the I2 to the primary side, then it is known as I2 dash. I2 dash is equal to I2 into K. That means we have to multiply I2 with K. And if you convert the voltages, what are the voltages? Load voltage V2. When it is converted to the primary side, it will be known as V2 dash. V2 dash will be equal to V2 divided by K. And similarly, secondary induced voltage E2 dash. E2 dash will be equal to E2 divided by K. These are the rules that we have to follow when we convert all the secondary parameters to the primary side. And the next rule, that is, if we transfer all the primary side parameters to the secondary side, then we have to follow some rules. At this condition, we are preparing an equivalent circuit referred to secondary. The same way, there will be three rules. If we transfer the resistance, reactance, and impedance, we have to multiply it with k square. That is, R1 dash will be equal to R1 into k square. And similarly, X1 dash will be equal to X1 into k square, and Z1 dash will be equal to Z1 into k square. No need for any load impedances. Load is connected at the secondary side. Similarly, if we convert the currents, primary current, that is I1, at the secondary, it will be I1 dash will be equal to I1 divided by K, and voltages, that is V1 dash will be equal to V1 into K, and E1 dash will be equal to E1 into K. These are the general rules that you have to remember for the problem calculation, and for the overall performance. These are the general rules that we have to apply. Okay. So thank you for watching. Thank you.